It's the vec3 class. Now let's see how to use this vec3 class as a module in another Python program. So to do that, first we need to create a new Python program within the same directory as where this vec3.py exists. So I've created a file called test_vec3.py. It exists under the same folder as vec3.py. And now let's look at test_vec3.py. So let me put this on the vertical tab so that we can put some breakpoints and check how these functions are called. The test_vec3.py now uses vec3 as a module. So notice the name of this file is vec3.py. So vec3 is the module name. Even though vec3 is a class, the name of the module will be the name of the file and not the class within it. So the statement from vec3 import star simply means that we want to import this module vec3 and use all the functionalities written within it in this file test_vec3.py. Now there is another way of importing a module. So we can simply write import vec3. What this does is it imports this file vec3, and now we can call any functionality within this vec3 file using the module name. So the syntax is module name dot functionality. The functionality here is a class, so module name dot vec3 will create a new instance of type vec3. If we don't write import vec3, if we simply write from vec3 import star, then we don't need to write this additional module name dot. We can ignore that and simply use the functionality that is part of the module. It is important to use import vec3 when we know that there can be some name collisions. To avoid name collisions, we should always use import vec3 and not from vec3 import star. I'm using from vec3 import star here because I know that there can be no name collisions. Okay, so now let's look at some examples. First, I'm creating two variables, a comma b. Both of them are of type vec3. A is initialized with value 1, 2, 3. B, we're creating a new object without passing any parameters. So the default argument will be used, which is 0, 0, 0. So let's run the program. And now let's check whether the __init method is called when we try to construct a new object. Notice I've put a breakpoint here into the __init method, which is now where the program has stopped. Let's look at what x, y, and z are. X is equal to 1, y is equal to 2, and z is equal to 3. These are the three parameters that were passed when we created this vec3 instance. So the __init method was automatically called. We did not invoke it. Python invoked it since we were trying to construct a new instance of type vec3. Once this function call completes, a will have three attributes. The three attributes are initialized with value equal to 1, 2, and 3. Now this function will be called again, this time with parameters 0, 0, 0 to initialize the vector, the variable b. And once this completes, now we can simply look at what a and b are. Now notice a is of type vec3. Its current parameters are 1, 2, and 3. Similarly, b is also of type vec3 and its parameters are all zeros. So we can simply pass a and b to the print function since we have written __str method within the vec3 class, and we can print a and b onto the console window. Now notice a is equal to 1, 2, 3, b is equal to 0, 0, 0. Now we can use the square brackets operator, as I mentioned before, to access a particular element. We know the first element of a is 1, so this should simply print 1. And now let's check what happens when we execute this expression 10 minus b. This should call r sub. Since the first operand is negative, is not of type vec3, it will call r sub instead of sub. So let's execute this line, and notice now it calls r sub, which is simply computing a new vec3 by treating v as a scalar and doing the subtraction component wise. So once this um, statement completes, once this statement is executed, we should see the result on the terminal. 10 minus b was 0, 0, 0, so 10 minus 0 is equal to 10, 10 minus 0 is again 10, 10 minus 0 is again 10. So the result is 10, 10, 10. Now we can use the plus equal to operator. We have not written an override for plus equal to. However, we've written an override for add. So when we call plus equal to, Python will simply call the add method. And now let's go to the add method and continue. Notice now the add method is called. First, it will check whether v is of type vec3. We know that v is not of type vec3. So it should simply go to the else and we should do an addition using the scalar. Okay, so similarly, the remaining a star equal to -2 will simply call the override mul. A minus equal to again will call the r sub. This time it will call sub because the operand is on the right hand side of the minus operator. The divided by equal to will simply call the true div method. So let's print a and b after all these occur. Now let's remove these breakpoints. Now notice it's simply called sub. It did not call the r sub when we are trying to subtract 10 from b. So b should be equal to 10. Now let's remove also this. And then let's look at a and b. Now after doing all these arithmetic operations, a is equal to -2, -3, -4, b is equal to -10, -10, -10. Now we can add these elements as part of a list by using the following syntax. So here when I write c is equal to square brackets a comma b, I'm creating a new list. The items or the elements of the list are now of type vec3. Okay, so we can use some inbuilt methods like sum to add the individual elements of this list and compute the sum of all the elements of this list. Since we have written the override for the __ add and r add, this function should compute the sum of the elements of this list which are of type vec3, and it should print the result back. Notice again the __ add method was called. So let's put a breakpoint here and then continue. Okay, so now a was -2, -3, -4, b was -10, -10, -10. So a plus b should be -12, -13, and -14, which is the correct result. So even though we created a new list by adding the vec3 objects as now elements or items of this list, and we used an inbuilt method sum to add the items of the list, everything works as expected because we wrote an override for the __ add method. Okay, now let's look at the static methods. So I'm creating two new vectors v1 and v2, and I want to call the dot product. So v1 is equal to 0, 4, 3, v2 is equal to 3, 4, 0, and to compute the dot product we can simply write vec3 dot dot. So vec3 is the name of the class. Within that class we have a static function dot, which takes two arguments, which are two vec3 objects. Okay, so let's compute the dot product, and now notice v1 dot v2 is equal to 16. Okay, so let's now put a breakpoint actually in the normalize function, and next I'm computing the norm of v1. So let's print norm of v1. Since we have 4, 3, 0, 4 square plus 3 square plus 0 square is 25. Square root of 25 is equal to 5. So v1 dot norm is equal to 5.0. And now when I call the normalize, notice I'm not using an instance or an object to call this method. I'm using the name of the class to call this method normalize, since it's a static method. So once we execute this line, it should break inside the normalize function. The normalize function is simply calling norm, so it should go to norm next, compute the norm, and then it will simply call the true div to divide the vector with a scalar. So actually I can use the step into function, and notice now it went to the true div method to do the division. First it will check whether v is of type vec3. We know it is not of type vec3, so it should go to else, and now it's just simply doing division by scalar. Okay, so once this method exits, we should see normalize of v1 should simply give us a unit vector, so 0, 0.8, 0.6 should be a unit vector. Okay, now finally we can use the equal to operator. So v1 dot norm will give us a scalar value, v2 dot norm gives us again a scalar value. We can use the equal to operator to check whether these two are equal. If v1 dot norm is equal to v2 dot norm, this should print a true, otherwise it prints a false. Okay, now notice since both of them have the same norm, this function returned a true. And now finally we can check whether v1 is equal to v2. This time the equal to operator will be the underscore eq method will be used. So let's put a breakpoint there and then execute this line. Notice this function is called. We know that these two vectors are not equal, so this should return a false. And v1 is not equal to v2. So this ends the topic on classes, functions, and modules. We looked at how to create new classes. We looked at the syntax for creating a new class. We looked at the syntax to create a new function. We saw how to create attributes within a class. We saw how to create class methods. The first parameter for a class method is always the implicit member, which is self. We will again use self to add attributes to our class. We looked at how to create static methods and how to use or call static methods. And finally, we saw how to use the functionalities written within a .py file as a module in another Python file. So I want to end this class by showing you how to execute more than one if you have more than one Python file within your project. So suppose you have more than one Python file, like in this case I have vec3.py and test_vec3.py. You can simply click on one of these two files. So let me now stop this code. You can right click one of the .py files and then you can click on set as startup file. So when you choose set as startup file, this particular file will be used to execute. So since I want test_vec3.py to be this file that needs to be executed, I will simply set this as a startup file. So vec3 is simply a module. I can use the import statement to import the functionalities of the vec3 file inside another file. This should hopefully help you in your next homework. And in our next class, we will see how we can use all of these concepts to create a practical program. Thank you.